Okay, let's begin. So basically what I'm doing here, this is just some bonus questions from chapter 5. The reasons I want to go through this is because, overall for exam prep, I want you guys to, solve this before I do them. And also at the end I'll have one question which will be really challenging. If you can do that, then you can do literally anything on the exam. If you can't do that, like it's fine, but if you do it, you're like finished, you're done. You can do anything you want. So let's start out with this question. These are all questions I just found online. I made this one up myself because it's relatively simple. So for this graph, x at y equals x squared and y equals x plus 6, find the intersection points between them. So what you can do is you can what is it? Solve the what is it? You can solve the two simultaneous equations, and you can get the values for both of these. So let's begin with let's begin with this. So let's label this one number 1 and let's label this one number 2. Equation number 2. You guys should be able to recall this. So let's start out with a simple one: y equals x plus 6, right? So the thing is, we can see that y equals x plus 6 and then y also equals x squared. So from here you can combine both equation 1 and 2. So you can say that x plus 6 is equal to x squared, right? That means from here what you can do is you can move all these to this side, so it'll be x squared minus x minus 6 is equal to 0, right? So x squared minus or plus 2x minus right now I'm factorizing, so minus 3x minus 6 is equal to 0. Then from the factorization you can conclude this answer: minus 3 x plus 2 is equal to 0. Therefore x plus 2 is equal to x minus 3, which means that, wait, therefore x is equal to minus 2, x is equal to plus 3, right? So now from here what you can do is to plug the values back in. So let's plug it into this formula, right? So if you plug into this formula, what you'll get is let's do this x1, x2. So, oh my bad, y1 is equal to 9, right? Well, y1 is equal to 4, right? Because you're squaring minus 2. Then y2 is equal to 9. So what we're just doing is you're plugging both of these into these equations right here. So we get y is equal to 4 and 9, so we can match these. Right. So if you look back into this diagram, this is minus 2. I kind of made it too small, but this is minus 2. The x value is minus 2 and the y value is 4. Now in this diagram, the y value is 9 while the x value is plus 3. This isn't accurate. I just drew this freehand, so the graph is wrong. But the thing is, I don't even think they'll give you the graph. They'll just tell you to do it yourself. So for the next question. So this is the next question to solve this simple simultaneous question, or this set of simultaneous equations. So here, also before you attempt any of these questions, try doing them yourself, just to see if you can do it. That's the whole point of the bonus chapter or bonus video. So from here, let's label this as 1 this as 2, right? So from here, you can conclude that y is equal to minus 4, or x minus 4 minus x, right? So that means that x squared plus y squared is actually just 4 minus x squared, which is equal to 10. So from here, what can you conclude? You can say that by using the algebraic identity here, you can conclude that this is 16 minus 8x plus x squared is equal to 10. And then here you can say that 2x squared minus 8x and then this is plus 6 is equal to 0, because you're moving this other side, so plus 6 equals 0. Now from here you can do whatever method you want. You can use a quadratic factorization, like quadratic formula for the factorization, or you can just factorize it yourself. So I'll just do that really quickly. Okay, so these are the values I got. I just used the the equation. So from here you can plug these back in, right? You can plug them back into the y equals 4 minus x equation. So from here, this is just this is just y1, which is y1 is equal to 1, right? And then y2 is equal to 3. So the answers are, or the coordinates are 3 by 1, or 3 and 1, and the next one is 1, 3. This is the answer to that. These are the coordinates. So these two are pretty simple answers. I think questions like this would probably come up. Now we're going to go to the harder one. If you guys can do this, you can pretty much do any single question on in chapter 5 for the CT, so CT for final term, whatever, doesn't matter. So let's get into that. Okay, so this is a question. Basically solve this question. Now, this seems pretty innocent until you look a bit closer. There's a lot of quadratics here, so it's a bit scary, but you can simplify this pretty well. So again, one last time, try to finish this without any help. If you can do this, you're pretty much set for everything. So let's begin with this part. So equation number 1, what is it? It's xy minus 3x plus 2y is equal to 6, right? So from here, you can write xy minus 3x plus 2y minus 6 is equal to 0. Now this is very unorthodox, and this is I don't think I've ever done this before in math at school, but what we're doing is you'll see for yourself. So x is y minus 3 plus 2 y minus 3 equals 0. So hey, this is very stupid. Normally you wouldn't do this. You wouldn't do this at all. From here you can conclude that x is equal to minus 2, y is equal to plus 3. So normally if you did this, if you're just solving one thing, then this would be really you wouldn't do this, right? But you're doing it simultaneous, so this is pretty fun to do. So we could both of these values, right? So we're gonna remember them. We're gonna use them till the very end. So for 2, Uh, the equation number 2 isn't really much. We can just uh, simplify it. So x squared plus 4y squared is equal to 5. Just I moved it. Now what we're gonna do, this is like part 2, so I should mention that. Part 2. You don't actually write this, but like this is basically the first part of the question. Now from here, if x is equal to minus 2, then we're gonna plug this in. We're gonna plug this in here, or we're gonna plug this in here, right? So minus 2 squared plus 4y squared is equal to 5. So if we just do some skipping, this is just 4, we move this other side, so 4y squared is equal to 1. That means y squared is equal to 1 by 4, and y is equal to plus or minus 1 by 2. Plus or minus 1 by 2, remember that. We just square rooting this, so we get square root of 1 is 1, and then square root of 4 is 2. So now we're going to go here, and if y is equal to 3, then x squared plus 4 into 3 square is equal to 5. I should write that better. 4 into 3 square is equal to 5, right? So, what that is, it's just x squared plus 36 is equal to 5. So this may start getting a bit suspicious here. This is just 9, 3 is 9, then 4, so 36. You're like, okay, this is kind of weird. This is minus 31. So x is equal to minus 31, or square root of minus 31. Now, hold this value, okay? This isn't possible. You already know this isn't possible, but let's just take this value and let's go to so we have both these values. Y is equal to 1 plus or minus 1 over 2, and x is equal to a root of 31, right, or minus 31. So this is the first case, okay? First case is when x is equal to minus 2, y is equal to 1 by 2, or minus 1 by 2, right? And the second case is when x is equal to minus 31, y is equal to 3, right? So we, in the real plane at least, we're not talking about an imaginary plane, we can conclude that, hey, this is not possible. This cannot lie on the graph. Cross that out. So this is not possible, right? So what's actually happening is that number 1 is true. Number 1 is the correct solve. So what we would do here is we just write down as the answer that the coordinates are minus 2, 1 by 2, or minus 2 minus 1 by 2. So this is the answer, right? Now, if you got this question, what this does is this basically concludes, like, we basically did everything here, including some things that were, like, you know, that are unorthodox, right? With, like, you know, this, for example, right? So we pretty much did everything in this one question. This is pretty hard. So Some other things to note is that in chapter 5, for word problems, we'll either get things like this or we'll get things like geometrical stuff. So I guess one thing you have to keep in mind is know what, like, know your geometry, know like what geometrical like things mean and stuff. Then like with circles and stuff, then you can form uh, what is it? You can form equations from those, right? And yeah, that's pretty much it. So if you did this, you could pretty much do anything you want. That's it for chapter 5. There's like nothing else for chapter 5. So, yep, that is about it. Goodbye.